So welcome students. So in this series what we are going to do is that we are going to go through everything that we require in geometry for IOQM, starting with very elementary notions of geometry and then going right up to the point from where so that you are able to grasp enough knowledge about the subject so that you are able to solve the questions that are ultimately asked. So this is a series that is meant for even students of 8th, 9th, 10th, provided I would request all of you who are sincerely pursuing it to go through your standard class text, standard text of your class so that you are not unfamiliar with the terminology that we are going to use. So first and foremost we must understand that what we read is Euclidean geometry. Okay. And all of you must have gone through Euclid's axioms and postulates. So I am okay. You must necessarily understand what an axiom or a postulate means. Axioms are facts that we take for granted, that we assume are true. We don't need to justify it. For example, one of the postulates is that there is only one line joining 2 points. So we just accept it as a fact. If you take 2 lines, we don't give a mathematical justification for it. We assume it to be true. Or from a line, from a point we can draw infinite lines. There are some very elementary notions that we take for granted. I hope all of you go through these, okay? They are inherent and intrinsic in understanding what geometry is. Or when you make any mathematical when we enter into any mathematical field, you will tend to understand what this means. Okay, so please have an idea of what axioms and postulates are. Theorems always require proof, that where we use axioms which we have already taken for granted, and then we apply it. Okay, so we must have a notion of theorems, what theorems mean. Then we have corollaries. Okay, so corollaries means something which can be established easily from the theorem. Theorems we prove theorem. Whatever theorems we use, we prove them. Corollaries are the key deduced from theorems. So to say, theorems are deduced from axioms. And then we deduce corollaries from the. So again, a very basic framework of any mathematical study, not only geometry. We must have the notion of what a point is, what a line is, what a plane is, okay. And we are only going to read planar geometry. Everything that we stick to lies in a plane, okay. So please be aware of those. What does two parallel line means? Okay, in Euclidean geometry, two parallel lines. These are two parallel lines. They will not meet. Okay, perpendicular lines. I hope you understand what does it mean. 90 degrees. This is called a transversal, a line intersecting other lines. This is called a transversal. These angles, you must be aware what they are. They are called vertically opposite angles. Okay. So this is say angle, this is some angle, say angle 1. This is angle 2. So you must know angle 1 is angle 2. They are called alternate interior angles. They are corresponding angles. Sorry, angle 3 plus angle 4 is 180 degrees. This is a right angle 90 degrees, 90 degrees. Less than 90 degrees acute angle, greater than 90 degrees obtuse angle. Very, very simple information I am providing, but just that we have to use it on and off continuously. So all of you must be aware of it. That is my sincere request that please go through basic texts so that you are able to understand and learn as we proceed in this series. Okay. This is again two parallel lines, L1, L2. L1 is parallel to L2. So for brevity we write it like this. L1 is parallel to L2. See, if these two lines are perpendicular, say L1, L2, for brevity say L1 is perpendicular to L2. Okay. This angle is 180 degree. Okay. Now angle 1, this is angle 2. Angle 1 and angle 2 are called supplementary angles. For right angles we can say angle 1 and angle 2 are called complementary. To each other. The moment we say one angle is supplementary to other, that means if one angle is x, other is 180 degree minus x. The moment we say one angle is complementary to other, we mean to say that if one angle is x, the other angle is 90 degree minus x. Okay. So these are very, very basic information. I am conveying it, lot of you, I believe all of you must be aware of it, but still we will be using it continuously in our discussion. So just whatever I am able to recall, okay, so that we get into the real things. Before that, we must be very, very, you must not only know it, you must be very fluent in all this. Okay. We must be very, very fluent. Suppose angle 1 plus angle 2 here is 90 degree. Here angle 1 plus angle 2 is 180 degree. Fine. Supplementary angles, their sum is 180 degree. Complementary angle, their sum is 180 degree, 90 degree, sorry. Okay. Moving ahead now, we generally talk of triangles. Triangles play a very important part. So triangle is polygon having 3 sides. Okay, this is the triangle. Okay, we denote its vertices by say ABC, and the sum of angles of a triangle is 180 degree. I hope you are able to prove it. What you do is you draw a line parallel to it. These two angles are equal. We just saw. See, these two angles are equal. So therefore, since these two are parallel lines, okay, they are alternate angles, alternate interior angles. Now this angle is equal to this angle. Again, because these two are parallel, and we just said that these two angles are going to be equal. Okay, so these two angles are going to be equal. Just look at it like this, suppose. Okay, just don't look at the third side. So, and similarly for here, you can say that you don't draw this line, this. These two angles are. So again, if this is angle A, this is angle A, this is angle B, this is angle B, and this is angle C. So angle A plus angle B, sum of sides of a triangle is 180 degree. Very, very useful thing. Again, further for a triangle, what we can say is that in a triangle, what is another important fact that we must keep in mind is that, sorry, so here angle C is greater than angle B in the diagrams. What we are saying is that this would imply side opposite to angle C is AB, AB is greater than AC. Okay, prove it. Please prove it. Okay, prove it. I am just writing it down. Okay, I would expect that you comment some of the things that I have directly used. If you feel that we need a proof for it, then please come forward so that we are able to further emphasize that what are the important points, further enlighten you. So I am just giving to you this is an exercise, that the side opposite to is larger. Fine. We use this fact sides opposite to larger side of a triangle is larger, to prove that sum of any two sides of a triangle inequality, sum of any two sides is greater than third side. Again, see, suppose this is a triangle. Okay, so what we do is that we have to show that, suppose we have to show that sum of any two sides is greater than the third side. So what we do is that we extend, see, we extend BA, so that AC is equal to AD, and we draw this triangle. Okay, so this angle is theta, sides opposite to equal angles are equal. These two are, again, the isosceles triangle. I hope you know what an isosceles triangle is. And then you can say BD what is it equal to? BA plus AD. What is BA plus AD? BA plus AC. Okay. Now you look at it very carefully. This is an additional angle. So what we can say is that in triangle BDC, angle BCD, this is how we write it, BCD is greater than angle BDC. What is BCD? This angle. So side BD will be greater than angle BDC. BDC opposite side is BC is greater than BC. So we have BC is less than BD, which is BA plus AC. Okay, we could have done it with any other thing. So what we generally do is that opposite to angle A, we write the side as A. We denote it by small a. Opposite to angle B, we say it is B, we say C. So we have BC. A we have just established, and similarly we have B, sum of any two sides is greater than the third side, and further we can say, second we can say of any two sides is less than third side. Are you able to see? See, B is greater than C minus A. Sorry, A minus you can write from the given, or C minus A you also can write. Okay, A minus C or C minus, whatever you like. B is greater than A minus C, B is also greater than C minus A. C is greater than A minus B, C is greater than B minus A. Whatever is the difference, generally we take positive, whatever. Either A minus B is positive or B minus A is positive. So these two things are very, 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 very helpful. Please have them on your tips. Suppose you are given that side, just suppose you are asked a question, how many triangles are there? Suppose somebody says, how many triangles are there? How many different triangles are there? Whose sides are integers? And perimeter is say 8. Okay, perimeter is 8. So how many triangles would be there? So what we will do is that we will start with smaller triangles. So suppose smaller triangles means some sides being lesser. So what you can very easily see is that suppose I take perimeter to be perimeter is 8. So smallest side I can say 1. And I take one of the sides to be 2. Or let us start with the smaller one. 1, 1. What can third side be? 6. So is it forming a triangle? Sum of any two side must be greater than the third side. So 1 plus 1, 2. It is not forming a triangle. Okay, it is not forming a triangle. Similarly, if I say 1, so the remaining is 7. So the next I have to take at least, so 1, 3, 4. This is also not forming a triangle. So if I take one side to be 1 and say 4, 1, 2, 5. Again, this is not a triangle. Further, I am only writing sides in increasing order. So this is not possible. 1, 2, 5, 1, 3, 4. So you are not getting any triangle. Okay. So none of the sides can be 1. Now if you start with 2, can we have a side 2, 2, 4. 2 plus 2 is 4. 2, 3, 3. This is the triangle. This is one triangle. What other triangle can we get? 2, 3, 3. Apart from 2, 3, 3, what is the triangle that you are able to fathom? See, 2 plus 3 is greater than 3, 3 plus 3 is greater than 2. So you can very easily see this is the triangle that we are getting. Any other triangle? Because the side is 8, we cannot take any side to be 4. We could have also ruled out them from this rationale also. The only triangle we are getting is the side with sides 2, 3, 3. You can say 3, 2, 3, but then they are effectively the same triangle. Okay. So if the perimeter is 8, and the triangle has sides integers, then the only possible triangle is triangle whose sides are 2, 3 and 3. Okay. Now, okay. Now one more question. See, thing I just thought of it, and one side of a triangle with integer sides is 1. Show that its perimeter is always an odd integer. Can you think of a triangle with side 1? So let us say, let the other sides so B is C greater than equal to C, or cell. Okay. So sides are B, C, 1. Okay. So B minus C, difference of any two sides. What we have seen, difference of any two sides is less than the third side. So B minus C is less than 1. And since B and C are integers with B minus C greater than equal to 0, this implies B is equal to C. Their difference has to be less than 1. So that means sides are B, B, 1. So perimeter is 2B plus 1. Okay. So we can say that they are always, the perimeter is always an odd number. What the other fact that we came to know is that if we have a triangle with integer sides and one of whose sides is 1, it will always be an isosceles triangle. Always be an isosceles triangle. Again, see how we are able to use it. Now, further for acute obtuse angle triangles, what we can say is that acute angle triangle assuming C. So, for acute angle triangle we have A square plus B square is less than, sorry, right angle triangle, everybody knows the Pythagoras theorem. And obtuse angle triangle. Okay, just see. Again, I am giving you an exercise. If you know this proof, okay, we must know them also. Obtuse angle triangle, you can understand one of the angles is greater than 90 degree. Here, all the angles are less than 90 degrees. Fine, so it is my request, and then in your comments, please do tell us if you are not able to prove it, then we will do so in our next engagement. In our next class, we will definitely prove them based on the queries that are raised. Okay. So sometimes you are asked about this also. So insofar as the questions in the examinations are concerned, even though we are in our very first lecture, some very basic notions are asked. So please be aware of this. Again, this is very relevant and useful when we solve problems. Sum of n, again very normal notions. All of you must be aware of all this, but again they play a significant part in solving problems that are asked in any competition, or you wish to learn and understand geometry. These things are important. Now, suppose somebody says, on this somebody asks a questions, find perimeter of a triangle whose sides are consecutive integers. And the triangle is first right angle. Okay. So, what we are looking for is a right angle triangle whose sides are consecutive integers. Say n, largest side would be the hypotenuse. So, if it is a right angle triangle, n square is n plus 2 whole square. Okay. Now, I am sure lot of you would have gone through a triangle like this. 3, 4, 5 is the obvious thing that people come up with. 2n square plus 2n plus 1 . So, you have so n is equal to 3. So, perimeter is 3 plus 4 plus 5, which is 12. Somebody may ask area, but purpose is that again this is a very simple triangle. I am sure all of you would have gone through this. 3, 4, 5 is considered a Pythagorean triplet, a very standard Pythagorean triplet, and it is expected that we are able to use it directly as and when required. So, this much amount of work is generally not done when we are asked about right angle triangle whose sides are 3 consecutive natural numbers. Then we directly write that the triangle concerned triangle is the triangle whose sides are 3, 4, 5. Now, suppose somebody says is an obtuse angle triangle. So, again sides are n, n plus 1, n plus 2. We want it to be an obtuse angle triangle. So, what is the condition that we will apply? A square plus b square is less than c square. That is okay. So, what do you get? So, you have n square so this is always positive. So, n minus 3 is less than 0, that is n is less than 3. Now, if n is less than 3, what can it be? 1 or 2. But with 1 we have already seen it has to be an isosceles triangle. So 1, you can also see that the sides are 1, 2, 3, which is not forming a triangle. Also we have seen that if a triangle with integer sides has one of its sides as 1, then it has to be an isosceles triangle, and we are taking all the 3 sides to be distinct, so n could not have been 1. If it is 2, the triangle is, so perimeter is 9. Okay. So this is the only triangle, you can see this is the only triangle whose sides are consecutive natural numbers and its perimeter is and it is an obtuse angle triangle. Barring, see, the moment we cross 2, 3, 4 is an obtuse angle triangle, 3, 4, 5 as we just got to know is or you were already aware of is right angle triangle. Post that any triangle with consecutive sides has to be an acute angle triangle. See, you can understand sum of consecutive squares. If you take 2 consecutive squares, as we move on to larger number, sum of 2 squares would definitely be, sum of 2 consecutive squares would definitely be exceeding the square of the number of the next number. So 6 squares, 7 squares, so their sum would definitely be exceeding 8 squares. So as we move on, we can possibly fathom it. For a smaller number, this is the only triangle. Right angle triangle with consecutive sides is 3, 4, 5. So I am requesting you to please remember it. Okay. So again, based on some very elementary notions of sum of 2 sides, we have been able to come up with the rationale that the utility of simple notions like triangle inequality is very useful in dealing with problems that we come across. We will do practice of notions like this continuously, but I deliberately chose to come to triangle inequality so that you come to know as to what are the sort of problems that we encounter. With a few very simple notions I have taken, very standard common notions. This is what we will come up with. Some very basic notion, some very elementary notions that we have gone through, and then what are the type of problems, what are the sort of situations that you handle, and the use of very simple, I would not say simple, very usual and commonplace theorems are used in solving problems, especially in examinations like Olympiad. A special care is taken that not some very arbitrary, not some very unknown facts are used in solving the problems. We have always come across situations where elementary notions are used in solving problems, especially in examinations like Olympiads. See, we have, in all the problems that we have gone through, we have simply used some elementary known facts in solving the problems. Okay. Now regarding triangles, let me also introduce you to the notion of congruency. Okay. Congruent figures you must all be aware of. If one figure can be superimposed upon other, then they are called congruent figures. So two triangles, for their congruency means they are one and the same, just as we said. These are one and the same triangle, that means they are congruent triangles. So the idea that would, rather than saying different triangles, the generally word uses non-congruent triangles. Okay. So congruency. So congruency, the types of congruency, what are the different conditions under which triangles are congruent. I hope you are aware of side, angle, side congruency. Okay. Angle, side, angle, 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 side, 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 and right hypotenuse side. Side angle side means you are dealing with two triangles. Sides and the included angle. Angle side angle would mean angle and the included side. Angle side would mean and a side opposite to any one of these angles. You could have taken this. Right hypotenuse side because one of the angle is given to be 90 degree. A lot of issues are sorted. Okay. Again, see angle side is not included here. Okay. So please keep in mind the order angle side angle. That means angle side angle, the two angles and the adjacent sides. Angle side angle side. Suppose these two sides are equal and suppose this angle is equal to say this angle, then we won't say that the triangles are congruent. The ordering does play a role. Okay. Now, so if two triangles are congruent, one can be superimposed on the other. Now see from here if somebody says this is ABC, this is PQR, and then I say BC is equal to QR. So we write it as CPCT. What does it stand for? Corresponding parts. Corresponding parts of congruent triangles. Corresponding parts of congruent triangles. Or we say that this angle is equal to this angle, angle ABC is equal to angle PQR. So we simply write CPCT. Why? Because they are corresponding parts of two congruent triangles, hence they are equal. So the congruency is very much used in dealing with problems. Congruency, and as we move on we will also see similarity. They are very important notions to be used in dealing with questions related to triangles, because if here what happens is that all the angles, all the sides are equal. Side I deliberately didn't draw a picture because side you can see all three sides are same. That ends the debate. Okay. Now, how do we utilize a bit of it? Suppose I draw a triangle. Okay. A, B, C, and say I draw a line AD. I take a point D, which is the midpoint of BC, and draw AD. Suppose somebody says show that AB plus AC is greater than 2AD. Okay. Now let me tell you that this AD, this is called median of the triangle. What is the median? Line joining vertex to the midpoint of opposite edge. We will have three such medians, one drawn from B, one drawn from C. One is drawn from A, one is drawn from B, one is drawn from C. As we move on, we will see that these three medians meet at a point. And lot of theorems related to it. What are the ratios? This point is called centroid. So what is the centroid? We will take up later on also. Point of intersection. So to get to 2AD, what we do is that we extend this. So let me draw this figure in on a new page. What we do is that we extend AD such that to a point E, such that AD is equal to D. Upon extend AD to E such that now suppose I join this. Now look at it very carefully. See, this is medians, these two are equal. Vertically opposite angles are always equal. So, triangle BDA and triangle CDE are congruent by which of the following things? You can see side, angle, side. Okay, side, side, included angle, and then side by SAS. What we write here is generally we write triangle BDA to triangle CD. Okay, they are similar to each other, and again very simply we can see. So therefore we have by triangle inequality sorry not triangle inequality. So we have AB is equal to CE. What we will write here, just now we learned CP corresponding part of congruent triangles. Now we will say by triangle inequality, what we have is that AB plus C is greater than AE. So we have AB. What is CE equal to? AB. No, AB not. Sorry. AC. What is CE equal to? CE equal to AB. Just now we have is greater than AE. Okay. Now what we have is that AE, and we just at the beginning said that we are extending AD in a manner such that AD is equal to DE. So effectively AE, what is AE? That is AD plus AD. So this is what we were supposed to prove. From this you can understand what we are going to write. AC plus AB is greater than 2 times AD. You can understand what we can write here from here if you further extend it. What is the corollary that you can draw from this? Suppose let me draw all the three medians. For the time being, assume that they are concurrent. So AB plus AC is greater than 2AD. Okay. CA to CE and BC you will get is greater than 2BE. Similarly, so you can very easily see that sum of the three sides of a triangle is greater than very elementary things. We will come up with better inequalities. This is a very raw inequality that we have come up with. Sum of any three sides of a triangle is greater than sum of the medians of the triangles. So it's simple triangle inequality and notions based on congruency. As we move on, we will focus more on congruency, idea of congruency and triangle inequality to deal with problems. So since this was our first lecture, I just wanted you to have a understanding, have a notion of how we are going to deal with these lectures. In the 12 lectures that we are going to have in this series of geometry, we will complete the geometry that is required to deal with the situations that we encounter in the examination of IOQM. Okay. So kids in 6th, 8th, 9th, 10th who are interested in appearing and excelling in examinations like this, I have been slow and I tried my best to be a bit docile, so that you are able to understand, you are able to fathom what the purpose of these lectures are. Some of the proofs I have left for you, and I'll come back, okay, and please comment, so that in next lecture if you ask, we'll tell the proofs of them. These two. The sides opposite to larger angle is larger. The notion of, okay, these notions I expect all of you to be aware of, and then as we move on, practice such things to learn the notions that we are going to go through in geometry. So, the basic idea of this lecture was that we are able to convey as to what we are going to do in the series, and please, and to make you aware, so that that a bit of preparedness is needed if we want to perform well and excel in examinations of this nature. So, I would request all of you to be in constant touch with the text that you have been provided with in your school. Please be a bit faster in going through the chapter of geometry, especially the books of NCERT of 8th, 9th, 10th, so that you are aware of the notions that we come across. Students of 6th, 7th would know what corresponding angles, would know what vertically opposite angles means, what supplementary and complementary angles means, what parallel lines mean, Euclid axioms, Euclid postulates would probably you are made aware in class 9th. So, if you are students of these classes, please go through these texts, whatever have been introduced. If you want some more details, please comment, so that when we come to next lecture, if you find something amiss, we are able to provide it. This will be a very comprehensive and all including series. I hope you would have learned something from today's lecture, and you will keep encouraging us so that we post more such videos. Thank you very much.